Hello friends, today we are going to see what is Cucumber and how to use that with Java. That said, Cucumber is a framework to facilitate the BDD. BDD is nothing but a business driven development, and it's an extension to test driven development, something that we already know. If you do not know what is test driven development, then I would like to take a minute to give a little bit overview on test driven development. So when we started testing our thing, we used to write unit test cases, basically JUnit, and then whenever we exposed a service, we used to write a JUnit to make sure that our service worked like what we expected. Then came the test driven development. So the methodology with test driven development was like, before even writing the service, we used to write all our test cases, and when we do not have the service developed, our test cases would fail, and then we would start writing the service implementation for those test cases. And as we write implementation, we keep running the test cases until all the test cases are passed. This is a very basic overview of what is test driven development. But there is a drawback with the test driven development. That's something I would say, like when we are too much focused on the test driven development, we get to deviate from the actual business requirement itself, because a test driven development would focus more on the how and the implementation part. When there is a change in the implementation part, we may have to go back and change the input parameters for those test cases, and we would expect certain output. So in the act of doing that, we may get deviated from what is the business requirement itself. So that's when BDD came into picture to solve some of those problems. As the name suggests, it is a business driven development. Basically, we would have the actual business requirement, and that would drive our test cases. And Cucumber is one of the such tool which will facilitate that. And there are other tools in the market that would do the same thing. For example, JBehave is something that we could consider as an alternative for Cucumber. In this video, we are going to see how to use Cucumber to accomplish the business driven development. That said, we'll get into the actual Cucumber APIs. So this is the dependencies that we need to work with Cucumber, and we need Cucumber Java and then the Cucumber JUnit in order to use Cucumber to test the Java services. And I would like to make this as a working session. So I'm going to create a simple project, and I'm going to create some services, and I'm going to write Cucumber acceptance test cases, and we are going to see how we can test this. And that said, I'm going to create my Eclipse project now. I'm going to create a Maven project, and like to use my default workspace, and I'm going to use Maven simple arch type. I'm going to use okay, basically Java. Okay, so now I have created a simple Maven project in order to write some services and test using Cucumber. So now this is my project, and I have my package. Let me get rid of the auto-generated class. So in this example, what I'm going to do is I'm going to create a calculator service, and let's see how to test that using Cucumber. So what I'm going to do is I'm going to create a calculator service. So calculator is my interface, and I'm going to expose to operation. So these are two abstract methods that I have in my calculator interface. I'm also going to create a implementation class for that. So what I'm going to do is I'm going to implement my calculator interface. So now I have given I have overdone those methods in my implementation class, and here I am going to give actual implementation to those. Okay. So what I have done now is I have created calculator interface, and that interface I have written to abstract method, and then I have gone ahead and created an implementation class, and that class implements calculator interface, and then it has to give implementation to those two abstract methods. And now we have got those two methods overdone, and I have got the implementation for those two methods. Now we have our service ready, and let's see how we can test this using Cucumber. So in order to test something using Cucumber, we need a feature. A feature is a file that is expected by Cucumber, and that file contains the feature and then the scenarios for our feature. And that's it. Let me go ahead and create a feature file so that we can see how we can test using that. So let me get rid of this class, and I'm going to. So did I include the dependencies? Okay, no, I have not yet included the dependency. Okay, let me include the dependencies that we saw here. So I'm going to add the dependencies to this POM file. Okay, so now I have added dependencies, and the Cucumber dependencies are added now, and I'm going to upgrade the JUnit version to 4.12. So this is what we need in order to use Cucumber and test run. So now we have taken care of dependencies. Now I am going to create a feature file. So feature file should go into test, and I'm going to create a resources. Okay. So inside the resources folder, I'm going to create a features folder. Basically, this feature folder holds all the features that we want to cover using Cucumber. So the feature that we are going to test now is a calculator feature. So I'm going to create a feature file in the name of calculator feature. So the extension for the feature file is always feature. So when you create a feature file, since I have Cucumber plugin installed in my Eclipse, it auto detects that, and then it adds the default thing. Whenever you create a feature file, and when you have a Cucumber plugin installed in your Eclipse, it will auto populate all these things. basically it says what is I mean who is the author for this file, and what are the key uh, uh, the key syntax for the feature file. And like I said, feature, scenario, given, when, then, these are the keywords that feature file will contain. And the feature file will follow a Gherkin language syntax, and that is the language that Cucumber API can understand, and it will generate the test cases out of that. And like I've said already, um, Cucumber framework will allow us to directly configure the feature and then the scenarios in the feature file. And let me go ahead and do that for the calculator, so that way you can understand what I'm talking about. So the feature that we are trying to test here is calculator feature. So I'm going to title it saying uh, calculator features. Okay. And I want to use this template to test my calculator features. Okay, and this is the basic let me get rid of this. I mean, you can have multiple scenarios as part of a feature file, but since we are going to test a single functionality out of calculator, so I'm going to limit this to a single scenario, and that scenario is going to test the add functionality of calculator to make it simple. So title should be scenarios to test add functionality of calculator. Gherkin language is very simple and it is easy to understand. This is the place where technical and non-technical people can work together, because non-technical people, basically you say someone who gives you requirement, can easily work on this feature file, and they can define what is the acceptance criteria for the feature or the scenarios that they want. So here I have mentioned that the scenario is to test the add functionality of the calculator. That said, the given we have to mention what is the precondition to test the calculator scenario. For that, I need to have a calculator. So given I have a calculator, given I have a calculator, and what is the condition, what is an action that you want to perform there. The action would be like, let's say that I have a calculator. When I pass two values, let's say 10 and 15. So basically when I pass two values 10 and 15, what is the expected? I want to get output as 25. So this is a very simple scenario. Let me reiterate what I have done so far. So basically I have my calculator service, and that will take care of certain calculator functions, and then I have gone ahead and created the feature file, which is the file which will contain all the feature and then the scenarios. And since we are dealing with calculator feature, so my feature file itself is a calculator, and then it has a scenario to test the add functionality in calculator. So the scenario would say to test add functionality of calculator, and what is a precondition? Precondition is a given, that is I have a calculator, and when I pass two values 10 and 15, I am expecting output as 25. This is a very basic acceptance criteria scenario. And now let's see how calculator will read this and how it will perform the test. So now we have got our feature file taken care, and now what I'm going to do is I'm going to create a basic test runner. So in the test package, I'm going to create test runner. The test runner, I need to mention what I'm going to use to run with. So run with going to use cucumber.class. So basically I'm going to run this test using the cucumber.class, and then there are certain options that we have to pass in order to read the feature file and test it. That's it. Cucumber has a predefined annotation which is cucumber options. So this is a predefined annotation that Cucumber has in it, and it expects a parameter to be passed in order to read those options. So first I would like to pass so here the features is an option that should have the value where is our feature files located. In this, if you look at it in the test resources, up to test resources we have it in the class path, and all our features are sitting inside the features folder. That's why I have mentioned up to class path, and then inside the class path look for the feature file inside this folder. So this folder basically contains all our feature. In our example we have a single feature file. There could be a scenario we may have so many features files and they could sit inside this folder. So we can simply point to the features folder, and the Cucumber during the runtime it can recognize the feature files are sitting inside this folder, and basically it will read and then it will perform the expected operation there. And so now we have pointed out our features folder, and let me go ahead and run this. So I have to run this like any other JUnit. Okay, so now I have run my test runner using the Cucumber class. So look here, it clearly says, I mean, it recognized our feature file, and it is saying you can implement missing steps in the snippet below. So it read our feature file, and it recognized our scenario, and it went through given, when, then, and it also finds it does not have any steps defined for this, and it has given us a some sort of code snippet. This is what it is expecting. For every step we have here, it has created a operation, and the name itself, it says I have a calculator, I have two values to be passed, and then I expect this output. And so now what we have to do is we have to define these steps somewhere, and then we have to give implementation. So let me go ahead and copy this. This is a cool feature that Cucumber offers. When it finds a feature file and it does not have any step defined, it auto generates the methods, and then it will flush it on the console. We can easily create our step definition using the default implementation. So now what I'm going to do is I'm going to create a step definition for this one, and let me name it as calculator step. So now I have created this class. Inside this class I'm going to paste those methods. When I do Control Shift O, it will auto import the necessary classes. And so now so this is our step definition, and so now we have got the step definition, and now we have got the feature. So there is an option called glue that we will have to use to glue the step definition to the test runner. Basically what we are saying is last time when we ran, it said that it did not find those steps, right? So now we have gone ahead and created the step definition, but somehow we have to let Cucumber know this is where my step definitions are sitting. So when you run our features, please recognize these steps and invoke the corresponding steps for the scenarios that have been defined in the feature file. So in order to mention that, the value for that is glue. Inside the using the glue parameter, we will have to mention where is our step definition file. And since it is part of this package, what I'm going to do is I'm going to take this package name, and we have to mention it here, saying that my step definitions are sitting inside this package. So you can have multiple step definitions, and you can just point out the package name. The runtime Cucumber will search for the step definition within this package. So now I have defined my step definition. So let me go ahead and run it, and let's see what happens. Okay, so now it says pending exception. So basically it has recognized the step definition, but none of the step definitions have implementation. And if you look at the step definition, basically it throws the pending exception. So that's what it says, that scenario 1 is pending, and 2 skipped because the first one itself threw exception saying pending exception. So now we have to give implementation to this step definition. So let's go ahead and give implementation to each of this method. So the first one is given. It says I have a calculator. So that means it is expecting a calculator instance to be created at this point of time. So what I'm going to do is I'm going to create a instance variable calculator. Basically this is an interface, and at this point of time when it says given I have a calculator, now I need to make sure that I instantiate the calculator and then give that reference to be held in this instance variable. So calculator equal to new calculator. I am here. So I have instantiated the calculator implementation object, and then I have passed a reference to that to the instance variable. So basically this instance variable holds the reference of the newly created calculator implementation class, and with that we are done with given. So given, that's what it says, I have a calculator. So basically we have created a calculator instance, and basically we have the calculator ready at this point of time. Now the second step would be I have two values. So basically the feature file is passing two values. When I pass two values 10 and 15, so this step gets executed, and I think we have to pay attention to these two things. So these two things are dynamic values that we are passing as part of the when step. So the when condition itself is passing these two values, and those two values are coming as a parameter to this method, and this is how this is the what to say, the regex created by the Cucumber. And if you look at it, it has a pattern saying that at this point of time it is expecting a dynamic value, then again it is expecting a dynamic value, and those values are passed to the method as a parameters. So so since it is an auto generated, it says argument 1 and argument 2. So let's just let us I and j. So those two values are coming from our feature file itself, and basically I holds 10 and j holds 15. So now what I'm going to do is, so I'm getting two values. So what I'm going to do, I'm going to capture those two values here. So now I'm holding those two values in the instance variable when this gets executed, and then so what I'm going to do at this point of time, I'm expecting an output. So basically I have two values, and that's what it says, right? When I pass, maybe we can just wait, and I pass two values, and when I pass two values 10 and 15 to add functionality. So this is more meaningful, right? So what I'm saying is I have, when I pass two values 10 and 15 to add functionality, and so let me so basically I have those two values, and I'm going to pass two values to the add functionality itself. So what we can do is we have the calculator instance here. So I'm going to pass those two values to this. Since I'm passing directly to the operation itself, I don't have to hold these values, and what I want to hold is only output that we get from that method. So at this point what I'm going to do is I'm going to hold the output. So basically when this condition gets executed, I'm passing those two values to the add operation, like we have mentioned here, I pass two values to add functionality, and that's what happens here. I mean, we have got two values, and we are passing those values to the add operation of the calculator instance, and then we are holding the output in the output instance variable, and then the expectation is I want to get output as 25. So when this gets executed, we need to make sure that whatever we are expecting is what we have received as an output. So I'm going to use JUnit assert, assert, assert same. So expected and then actual. The expected is what is passed from the feature itself. So the expected is 25 because I want output as 25. So I can expected, and actual, it could be output. So what we have done is we are the expected value is there, and then what we have received is already here. So it is going to assert what we have got and what is expected is same. So ignore this depreciation thing. So let's go ahead and run this. If I run my unit here, okay, so it says that this method has not been implemented because we changed the feature comment, right? That's what it says, that it cannot recognize this step definition because this definition is no longer valid because we changed the statement there. So now I just want to call it as I and J. So now we have taken care of that. So let me rerun it. Okay, so I have rerun that, and it says one scenario is tested and it is passed, and 3 steps are executed as part of that. So basically what it did, when I ran it, it went through the features folder and it saw only one feature file, and it has one scenario and 3 steps are there. And then we have also glued the step definition as part of that. So it was looking for the step definition. Of course, it recognized the calculator step definition, which is part of that package, and then it found the corresponding methods for the feature file steps, and then it executed each method for the steps, and then the expected output has the assert condition, which asserts the expected and the output. Let's say that for some reason I'm expecting 35. I'm just testing the negative. So 10 plus 15 should be 25, but by mistake I'm expecting 35, and let's see how it works. Okay, so here it has failed that scenario because we mentioned the incorrect output there, but actual add operation will add it and give 25. So that's why it is failing that. Expected 35 but received 25, but we should have mentioned it as a 25 here, plus 10 plus 15 should be 25. So if I mention positive, no, the expected output, and when I rerun it, it should get passed. There you go, it is passed now. So this is how we use Cucumber, and we test the business requirement. Here if you look at it, if you I mean, if you pay attention to it, in the feature file they mentioned the actual requirement. They want the add operation to be tested, and the business people knew what was their input and then what was their output. So they went ahead and wrote those scenario in this file, and also they gave it to us, and we plugged it into our feature folder, and we wrote the corresponding step definition. In the step definition we have used our services, and we validated the scenario that was mentioned in the feature file. So this is an example for the business driven development. So business is giving us the scenario, and we are using Cucumber to validate our services are complying with what is the actual expectation of the business. And this is a very basic example for the Cucumber, and I hope that you guys would have got what is Cucumber and how to use Cucumber. And in the next video we will see how to pass the multiple parameters to the same scenario, and we can also see how to generate the report using Cucumber. And thank you for watching this video. Bye bye.